For years, Toyota quietly built its name on reliability. Never flashy, always dependable. But that changed when the CEO made a rare, bold statement. Our new dynamic force engine will destroy the competition. This wasn't just hype, it marked a major shift in Toyota's strategy. What is the dynamic force engine? While many automakers are going all in on electric, Toyota is taking a different route. With its dynamic force engine lineup, Toyota is doubling down on fuel engines, making them more efficient, cleaner, and future-ready. These engines are central to Toyota's global platform, TNGA, Toyota New Global Architecture, which helps streamline car design and production. The goal? Build powerful engines that still meet tough emission standards, work with alternative fuels like ethanol and hydrogen, and perform reliably, especially in places where EVs aren't yet practical due to weak infrastructure. Why fuel engines still matter? In many parts of the world, EVs aren't realistic. Charging stations are limited, and power grids are unreliable. Toyota's bet is that highly efficient fuel engines still have a strong role to play. The dynamic force engines are designed to meet that need, delivering performance, fuel savings, and lower emissions. Built to fit TNGA vehicles, the same engine can be used in various models, from compact cars to SUVs, without redesigning everything. This shared platform lets Toyota produce vehicles faster, cut costs, and adapt quickly to changing market demands. What makes these engines different? The Dynamic Force series includes 3-cylinder, 4-cylinder, and V6 options. They're designed to run on multiple fuels and work with hybrid systems, giving Toyota flexibility across global markets. Key improvements. High thermal efficiency. Gas engines typically convert 30 to 33% of fuel into power. Toyota's dynamic force engines reach up to 40% and 41% in hybrids. Longer piston stroke boosts compression and efficiency. Dual injection system mixes direct and port injection for cleaner, stronger combustion. Advanced cooling, electric water pumps and smart temp control extend engine life and performance. Modular design. Same engine can be built in multiple countries using local parts, helping Toyota stay agile during supply chain disruptions. Competitive edge. As rivals rush to go fully electric, Toyota is covering more ground, refining both fuel and hybrid tech while prepping for a hydrogen future. The TNGA system keeps production efficient, while the dynamic force engines future-proof Toyota's lineup for markets where EVs aren't viable yet. Already, cars like the Corolla, Camry, and RAV4 are seeing gains in efficiency and performance thanks to these engines. The bigger picture. The Dynamic Force series isn't just a tweak, it's a complete rethinking of how fuel engines can work smarter. From combustion chamber design to airflow and ignition control, every detail is optimized to squeeze out more power with less fuel and fewer emissions. Toyota's engineers aimed high and delivered. By pushing thermal efficiency beyond what most thought possible for gas engines, they've made sure Toyota stays competitive in both today's and tomorrow's markets. This is more than just an engine upgrade. It's a statement. Toyota isn't just keeping up, it's setting the pace. Fuel injection has been one of the biggest advances in engine design. Toyota's dynamic force engines use a dual system called D4S, combining port injection, fuel sprayed into the intake manifold, and direct injection, fuel sent straight into the cylinder. Port injection keeps intake valves cleaner and works well at low speeds, while direct injection boosts power and efficiency under high load. By switching between or combining both methods, D4S improves fuel economy, power, and emissions under all driving conditions. To boost airflow and combustion, Toyota uses advanced materials and precise machining. Laser-cladded valve seats create smoother, more heat-resistant surfaces that reduce wear and help maintain consistent combustion. Intake ports are polished to a mirror finish, improving airflow and oxygen intake without needing a turbocharger. Toyota also upgraded valve timing. Instead of oil pressure, the intake camshaft now uses an electric motor, a system called VVTIE. This allows quicker and more precise control, especially during cold starts or light driving. Better valve timing improves fuel efficiency, emissions, and throttle response. Cooling is smarter too. Instead of one loop, these engines use separate channels for the head, block, and exhaust valves. This allows quicker warm-ups and better cooling when hot, improving performance, durability, and emissions. Sensors adjust flow based on real-time conditions. To reduce friction, a major source of energy loss, Toyota added low-friction coatings, roller rocker arms, improved oil flow, and a redesigned timing chain. These small changes combine to make the engine smoother, quieter, and more efficient. Meeting global emission standards is key. Fast-acting oxygen sensors and high-flow catalytic converters help cut emissions early. In hybrids, the engine shuts off when not needed and restarts cleanly when power is needed again. Made possible by TNGA's flexible design that supports both combustion and hybrid setups. Toyota also made these engines fuel flexible. In regions using ethanol or low-sulfur fuel, the engines run reliably without changes. They're also testing hydrogen combustion, burning hydrogen in a traditional engine, as seen in the GR Corolla H2 project. This could allow zero-emissions performance without switching to fuel cells. Part of the bigger picture, TNGA platform. The dynamic force engine is central to Toyota's TNGA, Toyota New Global Architecture strategy. TNGA makes it easy to use different engine sizes and hybrid setups across models, cutting costs and speeding up development. Whether it's a Camry in the US, a RAV4 in Europe, or a Corolla in Asia, the core engine tech remains consistent, efficient, responsive, and ready for the future. Global rollout and impact. The Camry was among the first to get the dynamic force engine, a 2.5L inline, 4, A25A FKS, with 203 horsepower and an optional hybrid setup with up to 208 horsepower. Hybrid trims push 50 miles per gallon, beating rivals like the Accord and Sonata. Next came the RAV4. Its hybrid version became the best-selling hybrid SUV in North America, thanks to its 40-plus mpg and strong performance. The Highlander followed, replacing V6 hybrids with a 2.5L engine delivering 243 horsepower and up to 36 miles per gallon combined. Toyota's dynamic force engine strategy. Toyota brought its high-efficiency dynamic force engines to compact cars with the 12th Gen Corolla. Gas models use the M20A FKS, while hybrids run on the M20A FXS, delivering over 50 miles per gallon and smoother, quieter performance. In Japan and Europe, smaller cars like the Yaris use 1.5L variants, M15A, FKS/FXE, pushing hybrid fuel economy past 60 miles per gallon on the TNGA-B platform. The CHR crossover also features these engines, with hybrid models gaining traction in Europe thanks to low emissions and tax incentives. Toyota tailors dynamic force engines to regional needs. Brazil and India use flex fuel variants for ethanol blends. North America and the Middle East pair the tech with larger V6 and V8 engines, while hybrid setups like the iForce Max twin-turbo V6 in the Tundra are gaining ground. In China, hybrids powered by the 2.0L version meet tight emission rules and rising demand. Lexus and performance integration. Lexus models also benefit. The ES250 uses the A25A FKS, while the ES300H runs on the hybrid A25A FXS. The UX, NX, and RX hybrids all integrate dynamic force engines, balancing smooth performance with efficiency. Even the new Toyota Crown pairs a dynamic force hybrid with AWD and sport-tuned electric motors, blending luxury, utility, and fuel savings. Toyota continues to lead fuel economy rankings, with low emissions helping meet tough regulations in the EU, Japan, and California. A smarter internal combustion path. Toyota's strategy isn't to abandon combustion, it's to evolve it. Dynamic force engines are among the most thermally efficient gas engines today, already achieving up to 43% thermal efficiency in hybrids. Toyota aims to push that beyond 45% with tech like high-speed combustion, lean burn, and next-gen intake systems. Dynamic force engines are being optimized to work hand-in-hand with electric systems. Future hybrids will rely on these engines to run only when most efficient, with predictive controls and geofencing to improve city driving. Dual-motor hybrid setups with electric AWD are also in development. Hydrogen combustion is another bold step. Unlike fuel cells, these engines burn hydrogen like gasoline. Modified dynamic force engines in cars like the Corolla Sport and GR Yaris have already shown strong performance with near-zero CO2 emissions, ideal for motorsports and regions with green hydrogen access. At the same time, Toyota continues investing in EVs, solid-state batteries, and fuel cells. Unlike rivals betting on a single path, Toyota's multi-pronged approach offers flexibility across markets. With unmatched scale, efficiency, and reliability, Toyota builds millions of these engines each year. Dynamic force isn't just a powertrain, it's a strategic pillar, showing that combustion can still play a vital role in a low-emission future. The question remains, will this engine be seen as Toyota's masterstroke or a missed opportunity in the race to electrify?